Dear students, so we are going to see matter in our surroundings. Okay, I think by 10 minutes we'll be able to complete it. Okay, so this is the 9th NCERT textbook, first chapter, matter in our surroundings. So we'll start. We just see how simple it is. 1, 2, 3, 4, 5, 6. Yeah, by 6 points you're going to just complete it. Okay, so we'll see how it is. Okay, simple and crisp. So first of all, what is matter? So matter is anything that has mass and occupies space. Mass means what? Yeah, weight and occupies space. For example, take, I can see iron box in front of me. So if I lift this iron box, it has a weight. That is nothing but the mass and occupies space. So it occupies some space in my table, right? So it can be considered as a matter. Simple explanation. That is, you can touch it. See, now I am holding iron box. I can see it. I can literally see it on my table or even feel its presence. When I touch it, I can hold it. Know that it's itself the presence. Therefore, it is a matter. So, if you need examples, it can be air. You can feel it, no? Okay. Next is water. Yes, when you touch it, you can feel it. Book. When you hold it, you can feel that mass and it occupies certain space, right, in your table. Yes. Then it's chalk. When a teacher holds a chalk, what it contains? Yes, it contains mass and it occupies space. And your body, if nothing is in front of you, just hold your hand and see. It has a certain mass and it occupies space, right? You're not invisible. You are occupying some space, whether it's in sofa or chair. Is it clear? Okay. So one line memory trick is matter is equal to mass plus space. Is it clear? Yes. So second point or the second topic is physical nature of matter. What it is? Yeah, physical nature. How it is physically nature of matter. Main idea is matter is made up of very tiny particles. That is the main idea. Matter is made up of particles. So the first point we have A, B, C and D. 4 points we have. The first one tells that matter is made up of particles. That means everything around us is made up of tiny, small particles that we cannot see with our eyes. Example, when you dissolve sugar in water, sugar particles spread everywhere. Okay, you are taking a spoon. Imagine you are taking a spoon, taking a sugar. Initially you can see the sugar. What about after dissolving it? Can you see it? Does that mean there is no sugar in the glass of water? No, there is sugar in the glass of water, but it's invisible. So, matter is made up of particles. Even though your glass has that sugar, you are not able to see. Everything around us is made up of very small particles. Since it's not visible, can we tell there is no matter? No, we are not able to see with our naked eyes. But it's still present. Is it clear? When you dissolve sugar in water, sugar particles spread everywhere. That is the first point. Matter is made up of particles. You can think the example of sugar in water. Very good. Okay. Second point is particles have space between them. We'll see the explanation. Particles are not tightly packed. There is empty space between them. Okay, so if you Google it, you can see the pictures of matter, how beautiful it's arranged like a bowls. First row, in higher classes you will learn it in detail, okay, like in your first PUC or 11th standard. So first layer, it's like, it's arranged in a beautiful pattern, many balls, you think it's arranged, and upon that, or not upon that, in between that two balls, one is kept in a triangular format. So beautifully it is arranged. So it has spaces. So if you can imagine that between, if you keep two balls and one ball is upon that, in between that one ball, if we arrange the balls in a triangular manner, whether there would be a space? Yes, there would be a space. That's what it is telling. Particles are not tightly packed. There is empty space between them. What is the example? Salt dissolves in water because salt particles fit into the spaces between water particles? And before we used to think it's just getting dissolved. Now you understand the science behind it. See, the water is having a space. In that space, salt is going and fitting into it. Very simple, right? Yes, so the second point is particle have space between them. What was the first point? In physical nature of matter, yeah, matter is made up of particles. Now we have learned particles have space between them. Is it clear? Very good. Third point is particles are continuously moving. What is the explanation? Particles never stay still. They are always moving. Example, perfume smell spreads across the room. So I am taking a perfume in my hand and I am spraying it. Okay. Now imagine, I'm just think that I'm next to you. Don't you get the smell? Just smell it. Ah, nice rose smell, isn't it? Yes, that's what. Particle never stays still. They are always moving. Didn't that perfume reach to you? Can't you smell it? Yes, you can smell it. That's what is meant. Particles are continuously moving. Is it clear? Okay, this was the third point. First one was matter is made up of particles. Then particles have space between them. Then was particles are continuously moving. And the fourth point is that particles attract each other. What is the explanation? Particles stick together because of attraction. Example, it is difficult to break a solid because of particles hold each other strongly. So what example can I give you in which that particles are combined like that? For example, you are going to drink the boost. Boost is the secret of my energy. So you have milk and you are adding that boost powder and you are dissolving it. Can you separate now? You want your milk back. Can I separate it now? No, I can't separate because there is an attraction between milk and boost. So it is difficult to break a solid. Now I am talking in the case of liquid. So in solid also similarly, if you mix two colors of red and yellow clay, you are mixing it together. After certain mixing, it would be a different color. Now after mixing nicely, can I remove it? Can I differentiate the red part and yellow part? No. Similarly, it happens to liquid also because particles hold each other very strongly. So particles attract each other is the fourth point. Is it clear? What were the 4 points of physical nature of matter? Yeah, first one was matter is made up of particles. Second is particles have space between them. Third one is particles are continuously moving. And fourth one is particles attract each other. Is it clear? Yes, that's it. We have completed 2 topics and now let's move to the third topic, that is states of matter. There are 3 main states. In your class you are just learning 3, but there are more. Is it clear? Okay. So first of all, solid. When I tell solid, what example you can think? You can think of a book. If a book is next to you, think about that. Okay. Properties. Hold a book in your hand. Yes. Now. Yes. Now, just feel it. Properties. Tell me whether it's right or not. I want you to repeat yes or no. Okay. Fixed shape. Whether it has a fixed shape, yes or no? Yes. Very good. Fixed volume. If you see the volume, it's a fixed. Whether it will change volume and all. No, it won't change. Next. Particles are tightly packed. Can you separate our paper is made up of many particles, no? Try separating the paper. It has many particles. No, it's a dumb question. You can't separate it. Next, is there a strong attraction? Can you, the same question I want to repeat. In paper, there is many things combined together. Can you try separating that? There is a strong attraction. No, you can't. That is in the case of solid. Is it clear? Example, stone, ice, book, anything you can give. Next, let's move to, this is under states of matter. What and all we have? Solid, liquid and gas. Second one is liquid. What are the properties of liquid? No fixed shape. Take a bottle and it should contain water. Okay, now you are pouring the water to a glass. Does the water take the shape of the glass? Yes. After pouring, while it was there in the bottle, the shape of the water, how was it? It was in the, how? Yes, it was in the shape of the bottle. As soon as I have poured into the glass, it has taken that shape. So whatever we are pouring it into, it will take that shape. Is it clear? Very good. Next is fixed volume. If you see the volume, what is it? Yeah, it will have a fixed volume. Next is particles are loosely packed. But in this one solid, it was very tightly packed. What will happen in the case of liquid? It's not that tightly packed. Liquid, no, so little more loosely they are packed. Is it clear? Next is moderate attraction. But between the books there was more attraction. But in the case of water, if we compare the solid and liquid, in the case of liquid there is no that much attraction. Is it clear? Example, water milk. I have told you in the case of boost what exactly happens. But if you consider the solid, book had more attraction than water and milk. Is it clear? Yes. Now let's move to the gas. What are the properties of gas? No fixed shape. Can you see whether like for example, okay, air around you, can you see it forming any shape? No, you can't see it any shape. No fixed volume. Can you weigh that air in a hand and tell, yeah, it contains this much volume? No, you can't tell that. Particles very far apart, isn't it? Like they are not closely held. One will be in a different place and it's very far. I told you in a solid they are very close to each other. This, if you separate your hands and move it into two directions, like how far it is, yeah, that much far would be it in the case of gas. Is it clear? Very good. Next is very weak attraction. I told solid has the strongest attraction, then liquid it's less, and in gas the attraction is very less. Is it clear? So what examples you can give? Air, oxygen, whatever is made up of gas, you can give it as an example. The fourth topic is change of state of matter. That means you are going to change it from solid to liquid, liquid to solid. Okay, we'll see what happens here. Meaning, matter can change from one state to another. It is telling that from one state, what are the states there? Solid, liquid and gas. It can change from one source to other. So, first of all, we'll see how it is in melting. In melting, what happens is the solid is converted to liquid. You can think a piece of ice you're keeping outside from refrigerator. So what happens that, yes, the ice is getting melted into water. Got it? That is nothing about melting. You naturally use it in your daily life. No, you will tell that ice has melted. That means it is converting. A piece of ice is converting into water. That is nothing but melting. Now let's see freezing. How do you use freezer? Yeah, you will take, now it's summer, right? You will take the water bottle filled with water and you will keep in refrigerator. After some time it's freezing. So solid is converted into, liquid is converted into solid. For example, water is converted into what? Yes, it is converted into ice. Is it clear? Okay. Next, we are going to see vaporization. What is it, students? Yes, vaporization. That is, liquid is converting into gas. For example, water is converting into steam. Okay, you are boiling water. And what happens if it reaches certain point, 100 degrees Celsius? It's started making that bubbles. Yeah, and the more you heat them, the more it gets evaporated, isn't it? For example, if we keep our clothes outside for drying, what happens to the liquid in that? The water moves as vapor into the atmosphere. That is nothing but the vaporization. Is it clear? Yes, very good. Next is the condensation. Condensation means what? The gas is converted into the liquid. Example, steam into water droplets. Okay, you think your mother has prepared something very hot, very delicious, and let it be biryani. Okay, so what you're doing is you're just removing the lid and see. So the steam what has moved upward towards the lid, the moment you shake it or take it out, it drops down as liquid water droplets. That is nothing but the condensation. Is it clear? We get rain, right? Similar way we get rain also. Like it in clouds it would be water vapor, and when it becomes heavy it comes as water droplets or rainwater. Is it clear? So the gas is converting into liquid. is called condensation. That is steam. A very simple example, that is steam is getting converted into water droplets. Is it clear? Next is very important, that is sublimation. What is sublimation? We actually know from solid it will get converted into liquid, then to gas. But here what happens is the solid is directly getting converted into gas. That is camphor. I remember one of our teacher, she performed this experiment. She took a camphor in one of the spatula and burnt it. The moment the solid camphor was burnt, what happened is it turned into a gas. We could just see the gas, okay, not any water or anything. So if you have naphthalene bowls, like we store it at homes, no, for preservation and all. So if you have, you can just, with your parents' permission, you can just burn it and see. The moment it's burned, what happens? The solid is converted into gas. Is it clear, students? So we have completed 4 topics and only 2 more is left. We'll complete that too. Okay, next is a very small topic. It is factors affecting change of state. What are the factors affecting? Now I told the solid will change to liquid, liquid will change to gas, solid will change to gas. So there are certain factors which is affecting this change. Let's see, only there are 2 factors. One is temperature and one is the pressure. We'll see what is about the temperature. Explanation. When temperature increases, particles move faster. Example, ice melts when heated, isn't it? If you are keeping ice, if you are waiting in the room temperature, it will melt. But the moment you apply that heat, what happens? It will start melting very quickly, isn't it? Okay. Is it clear? Okay. Next is, that is, explanation is when temperature increases, particles move faster. So what happens in one more idea I will give you. In ice, it was solid and there was strong attraction. When heated, that attraction has reduced and it is able to move faster. Can you relate like that also? Yes, very good. Next is the pressure. What is pressure? Increasing pressure brings particles together, that is closer. So when you increase the pressure, what happens to the particles? Yes, it becomes very closer. Example, gas can be converted into liquid on high pressure. See, I told in gas what it has less attraction. I told you to keep your 2 hands apart. So that far is the attraction, that is very less. So the moment you start applying pressure, no, the particles bring both your hands closer. The moment you start applying pressure, the both hands come together. Both hands are nothing but the gas you have. What happens when your hands are getting closer? There is an attraction, no? When it's far, is there any attraction? No. The moment your hands are getting closer, there is an attraction. Is it clear? Very good. So, we were talking about, yes, pressure. How the pressure, that is increasing pressure, what will happen? It will brings the particles closer. That is, gas can be converted into liquid by high pressure. Is it clear, students? Yes. Now the 6th point is evaporation. So we have completed what? Factors affecting the change of state, that is temperature and pressure. I think you have understood it very well. Good. Next is evaporation. What is evaporation? Evaporation is the change of liquid into vapor at any temperature. Simple example, wet clothes drying. What is happening is evaporation is a change of liquid. From liquid, it is changing into vapor. Liquid is getting converted into gas. From your wet clothes, the liquid is moving and converting into gas, and it's moving to the atmosphere at any temperature. Temperature is never a matter here, okay? So wet clothes drying, but if the temperature is high, like if we have good sunlight, it is easier for it to take place, isn't it? You have noticed during rainy season, the clothes, it takes lot of time to get it dried. So temperature is also a part, but it's telling that even though evaporation will take place, even in rainy seasons, your clothes will dry, isn't it? Okay. What are the factors affecting evaporation? What and all? One is surface area. How can you tell surface area? What will happen if you add clothes upon one like that? Like stock, if you add, you don't, right? Like just think, you are putting the clothes for drying one upon, first you have put one dress, upon that another. Is it the method? No, you have to spread it so that evaporation will take place easier. Second one is temperature. If there is good temperature, yes, it will get dried soon. Third is the wind speed. If there is more wind speed, yes, it will carry the water vapor. Liquid is converted to water vapor and it is carried easily. And the fourth one is humidity, that is the presence of moisture in the atmosphere. So that also results, these are the factors affecting evaporation. So this memory trick it has given is surface area, temperature, wind, humidity, STWH. I think it's very easy to, you just memorize it through that visual thing, so that it would be easy for you to remember. So it's all, we have completed this unit. Okay, I hope you have understood. Thank you, students.